Hey everyone, sorry I couldn't be with you today. I'm having that field trip. I want to make a screencastify so I could at least give you some instruction to help you with this chapter. There'll be a second video giving you information or telling you directions on how to use this information in some kind of interactive assignment. So please watch the second video so you know what to do with the information I'm giving you. Also check your Google Classroom on Saturday night, uh, not Saturday night, on Saturday around 5, which will help you, which I'll give you some information that will help you with your SOL packet. And again, at pages 25 through 31 on your SOL packet, at least I believe those are the pages. I know you can see what I see, so I'm going to pull the PowerPoint up. You guys can write down some of these notes if you'd like. If not, you can just listen to me as I'm giving this information and get the notes off your Google Classroom on Saturday afternoon. We have been talking about for the last couple of days, talking about molds and casts and fossils and radioactive dating and evolution and so forth. Yesterday we talked about a mold, a fossil that's mold, which is a mold of the fossil, which is basically just an imprint. And then we talked about cast, which a cast is a 3D rendering of the actual fossil. And then the trace fossil. The trace fossil can give you a lot of information on how the animal lived. It can be something as simple as a footprint. We can infer information, or you can infer information with regards to even from how the poo of an animal. Just to be blunt, you can see what they ate and the type of animals that were in its environment and what it did eat on, whether it was a herbivore, omnivore, or carnivore. So I'm going to type in trace fossils right here, and imagine I'm going to pull up a variety of different things. There's a starfish footprints. It's like some squiggly patterns and maybe worms. Again, footprints again. There's a type of leaf. So that's a cast. It's not really a imprint there. So imprints, I'll give you an example of imprints and information we can gather from something as simple as an imprint. All right, let me go back to the PowerPoint. In Virginia, fossils in Virginia. Virginia basically had it all. They had fossils from every era, even from the Paleozoic, which included the Cambrian and Precambrian. The older fossils were mainly found in the Valley and Ridge and the Appalachian Plateau, and the newer fossils, more modern fossils, are going to be found in your coastal plain region. But again, in Virginia, we had them all. You have something as simple as the soft-bodied or soft-bodied animals that exist in the Precambrian. I'll show you a picture of that in 1 second. So most Virginia fossils are marine organisms because Virginia used to be covered by the ocean, especially when we're talking about Pangea and and Africa when they were colliding. And how the Blue Ridge Mountains or Appalachian Mountains were formed. That the whole state of Virginia was covered by the ocean at one time. And thereafter, different times after that, it was submerged also. So lots of fossils in Virginia. Those are the three main regions. Piedmont, you're going out your backyard, you're not really going to find fossils. It'd be harder to. I'm not saying they're not there, but less likely. So these are the three regions that have the most amount of fossils. Down here on the next slide, you'll see that Paleozoic, Mesozoic, and Cenozoic are all demonstrated in Virginia. In this picture right here that you see on this page, you can see that they're probably diatoms or some kind of worm type animal that existed during the Paleozoic. How I know that is because I looked at this image. I found the information that was displayed on the web page, and this guy's demonstrating some of the early life forms on this planet existing in Virginia. Again, the Paleozoic is broken down into two subcategories, the Precambrian and Cambrian. The Precambrian, you're going to have some of your most basic life forms, bacteria. You're going to have some worms and some leafy type organisms. And then the Cambrian is the explosion. You have tons of invertebrates, and a little bit later on in the Cambrian, you have jawless fish arising, and then from there on after you have more advanced life forms appearing on the Earth. So the Mesozoic, why they're so popular, why that era is so popular, and what the SWO wants you to know about it is because of the dinosaurs. Who doesn't like dinosaurs, right? And the Cenozoic is more modern animals, definitely modern modern mammals, and even humans exist in the Cenozoic. All right. Hopefully you had enough time to write that information down. I'm going to jump now to the next slide. Remember, I only have 10 minutes to do this presentation because that's all this program allows me to do. I'm going to go now to something called the law of superposition. And the law of superposition states that in the most basic form, that the older layers on the bottom and the younger layers on top. What's going on in this image is something called an unconformity. Part of the geological record's missing, and you have learned about weathering and erosion, so you should know that that's easily that happens all the time. So this is a real possibility. And even this one, as easy as this model is showing an unconformity, because in nature, you don't have things just laying down nice and perfect and neat a lot of the times. Most of the time, things are missing, information's missing because of forces of nature's messing everything up. So in this most basic form, if you see something like this, yes, the oldest layer is on the bottom and the youngest layer is on top. Unconformities, again, is part of the geological record is missing from weathering, erosion, earthquakes, or volcanoes. So let's get to where it's a little bit more complicated because that's what's more common, and that's on the next slide. In this slide, you can see it's all mixed up, and this is what the geologist typically encounters. I'm going to go through this with you and show you the order of events, what happened. It's actually A, B, C, D. It's already ordered for you, but I'm going to explain it. Okay, A here is basically a layer of sediment that was laid down. Then came something called an intrusion. And an intrusion is basically a magma spill into that layer of rock. So this is the oldest, and this is the next oldest. Now, after this magma intrusion came in, we have another sediment layer coming down and filling that area in right here. So that's C. So that would be deposition. An area has been deposited here through just flooding. Look what happens next, though. We have another magma intrusion. And that intrusion pops up right through here, and you just imagine it's spilling some of its magma down right here on top of that. Then we have another sediment layer being deposited, and that would be shown by this E right here. So E is depositing here, and that's where we have modern grass. You see the grass, you see a little stream area going through here, so kind of what we see when you walk outside. However, the last thing happens is a fault. So basically an earthquake happened and it shifted this material up. So again, A, oldest layer, B, next oldest layer, C, deposition occurring, another magma intrusion, another deposit layer, and then an earthquake. Now this one was easy because it was already labeled out for you. On Monday, Tuesday, Wednesday, you're going to have practice where things are not laid out for you. You're going to have to figure out what happens first, then next, then next, then next. Okay? Hopefully you guys had enough time to write that. Going to your last slide before I end this. So hope you're following along and keeping up with me. All right, the last one just goes into intrusions and unconformities and faults a little bit more in detail, and they actually show you real pictures where the others were just like artist renderings of it. This first one is that's an intrusion. You have this layer of rock that was laid down, and then a magma intrusion coming up in between it. So this rock layer, these rock layers were the oldest, and this is the youngest popping up through it. Okay, so that's an intrusion. So the intrusion is always younger than the surrounding rock that's right next to it. Over here we have a fault. You had the strata layers being laid down nice and perfect. You can see I only have 30 seconds left. And then the fault occurred and it dropped. So the fault is always younger than the surrounding also. 20 seconds. And my last thing here is an anticline and a syncline. Part of this is the unconformity. Part of the area is washed away because you see you're missing stuff right here because it was going up. and then we have some deposition coming in and filling in the missing part. Thank you for watching. See you Monday.